this one I find is we deal with pulse laser systems all the time. And to do that, you're going to be using a capacitor, is what creates the electrical energy. And the example that showed up here when I was in one of my postdocs, we had a pulse ruby laser, and that was a 400 microfarad capacitor. We charged at 2.8 kilovolts. That's, and I mean, the capacitor about the size of a small suitcase. Okay, well, one of the electronics guys there, well, I let him do it. He worked out a way to measure the peak current going through the flash lamp on the laser, and it was in excess of 10,000 amperes. I just stood on the other side of the room and let him measure it. Then looked at. If you can imagine what would happen if you touched the wrong thing on that capacitor, it would be like getting hit by a subway train. It would literally throw you across the room and you would not get back up. And so it was really a critical factor when we dealt with any pulse laser system, because we'd have to go down and make sure that the capacitor, if we had to go in and change the capacitors to change the pulse duration on the laser, you had to make sure that they were all discharged. And we used what they called a Jesus stick. It was a insulated rod with a hook shaped of a J on the end and connected to a grounding strap. And word was that if you didn't do that, you might just end up seeing your savior in the next life. So the electrical problem is an extremely hazardous one. Fortunately, now in more and more of the pulse laser welding systems, you do all that from the keyboard.